everyone. This is a class on electric circuit, and in this class we'll discuss about the different connections, that is series connection and parallel connection. In the last class we have already discussed the series connection. Now we'll go into the parallel connection. We know that in parallel connection the voltage across the elements is same and we can add the admittance of elements which are in parallel. Let's draw the circuit. Consider two resistors connected in parallel. The voltage across it is V. Current through it is I. Now the current flowing through each of this is I1 and I2. This is the resistor R1, this is the resistor R2. Now in the parallel connection, the voltage across both the resistors will be equal, that is capital V. Now the equivalent resistance. How to find the equivalent resistance? In a parallel connection, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Okay. This can be written as R equivalent is equal to R1 R2 divided by R1 plus R2. What if there are n number of resistors, n resistors in parallel? Now the equivalent resistance will be 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus etc. 1 by Rn. Okay, now if there are n equal resistors in parallel, and the equivalent resistance will be 1 by R equivalent is equal to 1 by R plus 1 by R plus etc. 1 by R. That is n times. So we can write it as n divided by R. If there are n equal resistors connected in parallel, then 1 by R equivalent is equal to n divided by R. Or that is R equivalent is equal to, we take the reciprocal, that is R by n. So this is about the parallel connection equivalent resistance. Next we will see the voltage division rule. When elements are connected in parallel, to find the current through each element we apply the voltage division rule. That is, there are two resistors connected in parallel. Applied voltage is V, the total current is I. This is R1, this is R2, and if the current through this is I1, current through I2 is R2 is I2. Now we have to find the current through the resistors R1 and R2. That is, the current is I1 and I2. That is, to find I1, current through R1. That is, I1 is equal to total current I into the other resistor, that is R2, divided by the total resistance R1 plus R2. This is the current through resistor R1. Similarly, current through resistor R2, that is I2 is equal to total current, that is I, into the other resistor, that is R1, divided by the total resistance R1 plus R2. This is the current division rule. Using this rule we can find the current through any element which are connected in parallel. Next we will see a problem related to this. Given a circuit, there are two resistors, 2 ohm and 5 ohm, connected in parallel, and the total current through it is 10 amps. Now the first question is find the equivalent resistance, and second, find the current through the 2 ohm resistor. Okay, first we will find the R equivalent. We know that in a parallel connection 1 by R equivalent is equal to 1 by R1 plus 1 by R2 if there are two resistors. That is R equivalent is equal to R1 R2 divided by R1 plus R2. Here given that R1 is equal to 2 ohm, R2 equal to 5 ohm. Now the R equivalent will be 2 into 5 divided by 2 plus 5. That is 10 by 7 ohms. This is the R equivalent. Now second, find the current through the 2 ohm resistor. To find this current I1, we have to apply the current division rule. That is I1 is equal to total current I into the other resistor, that is R2, divided by R1 plus R2. So we'll substitute current I is 10 amps, other resistor is 5, divided by total resistance 2 plus 5, that is 50 divided by 7 amps. So this is the current that is flowing through the 2 ohm resistor. So this is all about the parallel connection.